Well, hi, and welcome to my shop here. It's February 20th, and I'm going to do a short recap on where I stand with this radio, and then I'm going to tell you what I'm going to do next to it. So far I've tested the tubes. I've replaced one defective tube with this rectifier tube. I've changed all the capacitors, old capacitors in it. And as I've been doing this, the radio's performance, which has never been very good at all, has been going downhill. So the last stage of capacitor replacement and the radio's performance pretty much disappeared. It couldn't pick up any more stations. That's what I really want to say. So that's a little bit of a surprising result. You'd think as you put in newer capacitors, the radio would only improve in operation. But this one hasn't. So what are the possibilities? One, I've made a mistake in how I put those capacitors in. That's always possible. I was really careful. Pretty sure I didn't get it wrong, but that's possible. Another one is the radio is so far out of alignment that it's behaving the way it is. It's just no signals getting through it, and alignment would correct that. Another possibility is there's more defective components in the radio, particular resistors I haven't found because I really haven't gone looking for them all that hard. And I think that's where I'm going to start today, because this radio schematic comes with some very valuable information in this little chart right here. And this is showing the expected voltages on the pins of the different tubes. So I'm going to check all the voltages that are in this radio and compare them to the chart here and see if there aren't some anomalies, especially a missing voltage would be a really big find. I kind of don't think it's going to be that serious, but maybe we'll find something that's out far enough that correcting that might improve the operation of the radio. So we got to poke around underneath here the whole time we're doing this. Okay, let's start it up, because the last time I started it up it worked unexpectedly. Maybe it'll do that again. Volume down, switch is on, plug is in. Start a little low, away we go. Okay, dim bulb's doing the usual thing, so we're just going to skip right past them. We're running the set around 100 volts. Let's just do like 110 or so. When we go to do the measurements, we have to make sure the voltage at the radio is correct. Okay, any sound? Boy, oh boy, oh boy. We're at 108 volts. Not a thing. Oh boy. I was hoping it would spring to life, but it's sprung to death here. Well, tubes are lit up. That's really, really quiet. A little signal injection. Well, maybe it's really quiet because I don't have an antenna on it. Well, that might be the reason. That would be why it's quiet compared to its behavior yesterday, of course. So I'll put this on now. This antenna is actually not, the switch is not on, so what is up? A little bit there. There we are. So it's very, very quiet, isn't it? And when I touch the grid of the preamp amplifier here, the audio preamp, it doesn't produce an awful lot of sound when it really should. A lot of weakness maybe in the final output stage. Okay, so we don't need this. In fact, the instructions are short the antenna. I think I'm just going to leave it hanging open for now. Don't think it's going to matter. I'm going to make sure we are feeding the set width. This gives it right here somewhere. Well, I can't spot it now. There we are, 115 volts. 108. We got 115 right on the outlet, right on the plug here. There's no argument about that. Okay. Voltmeter. Nice high voltage terminal exposed right there. And we'll start with that. That's a 500 volt scale. That's 300 volts in the radio. Okay, so we're going to look for B plus way up in the top here. Am I going to put my elbow in front of the camera all the time? And the answer is yes. He's gonna do that. You know what? I can drop the camera a little bit here. This might be just a teeny tiny bit better. Not really. Okay, B plus on this tube. Yep. So B plus going through the radio. Now we're going to start doing these measurements here. Looking at the tube layout. Yeah, that's correct. Okay, so we're going to start right down here with the rectifier tube. First two tests are the output of the transformer, really. 285 AC. I have a little bit of trouble reading the sheet here. It's either 205 or 285 AC. Okay, and we want to get on to pins number. Oh, they haven't numbered them. Wow, they haven't done any favors here the way they've done this. Oh, now they are. Actually, they show the key here. Key 0325. Let's start down here. Raise the key up a little bit. Yeah, okay, so this shows the tube keys as they are in the radio. So it's very, very pictorial here. Give me just a wee bit more light. Okay. One, two, three, 4 should give me the reading of 285 volts, 500 volt scale, so it should go just up here. That's what we're looking for. If it's not that pin, it must be this one. Okay, if it's not that one, the only one it can be is this one. Oh my gosh, what was that? It's just the meter connection. Well, okay, so I'm getting 200 volts there. Not 285. that really the right pin? This is way low. This is way low. So it says 285 without a doubt. AC. It should appear on two plates. On the two plates, one pin apart. So we're getting it here. That's basically exactly 200 volts. 85 short. And then the other one is here. Ooh, not there. Am I getting this right? I'm not sure I'm counting this right at all. Cannot. I'm not sure what I did there. 1, 2, 3, 4, and 6 are the pins I want to go on. So I'll do it by counting because the pictorial thing's not working for me. 1, 2, 3, 4, 5. This is 6. 200. Didn't I say 4? 200. So it was only 200 instead of 285. And we're certainly on the right input voltage. Well, I don't know. I don't know what to say about that. Well, let's look at some of the DC voltages here and we'll see what we get. We should get 325 DC on the heater, which is pin 8. If we go pin 8, we should get a DC voltage. Pin 8, that's this one here. So there we're getting 350, 360, 350, 360, and it's supposed to be, son of a gun, 280. What the heck is going on? You know, I'm reading the wrong, my eye is slipping on this chart. It's supposed to be 270 AC, we get 200. Supposed to be 280 DC, we get 3 something. So one way you could get a high voltage there, DC voltage, is there isn't as much draw in the radio as expected. And that could be because there's an open resistor somewhere in here and some tube's not getting its voltage and not doing its current thing. Part of its voltage anyway. Okay, that's all kind of mysterious. And I got a nice foggy start here. Let's carry on. Oh, look, you know what I'm doing? Oh my god, you know what I'm doing? I'm flipping from radio to radio. That's what I'm doing here. Come on. Put an end to that. Let me put an end to that. Don't make that stupid mistake here. Okay, onward. So let's take a look at the next. Let's take a look at the output tube. 6F6. It's going to be that guy. Okay, and he is supposed to have starting on pin 3, we should find 245 volts. Pin 3, 245. Pin 3. Correct tube. Yes. 1, 2, 3. Right here. We got supposed to be, what did I say, 245? And we're actually got 275. That's reflective of the high B+. We get another high voltage on this tube, the next pin, right here. 300 volts. And the chart is suggesting 245. That's a lot higher. That's a lot higher. Okay, let's just go on to the 6H6 now, which is this tube here. There's really no voltages, just zeros everywhere. Some note here I can't read. C note. The note is C note B. C note B. So note B, the grid bias. So this is the note about where to read the grid biases off these resistors down here. We'll get to that. Well, okay, we can't do much with the detector tube then, really. Just says 6 volts AC on the heater. I'm not too worried about that. Okay, we'll just go on to the next tube then. This is the audio preamp. Output tube, audio preamp here. The audio preamp tube. (120 volts) on pin number 1, 2, 3, 4. Pin number 4. Pin number 4. So we go 1, 2, 3. This one here. So it's supposed to be 120 volts. It's 220. It's just way high. Let me just make sure I'm reading 120 there. 120, and we're way high, but it's there. I mean, the thing is, the voltage is there. Okay, so now we're down to 2 remaining tubes here. Well, these guys better help me out. So we go 1, 2, 3. Pin 3 should have 255 volts on it. Pin 3 on this tube. Pin 3, 1, 2, 3. This one here. Ooh. Must have how much? Got some life out of the radio. 255 volts on the 3rd pin. So 255 is pretty much straight up here on pin 3. And this is key 1, 2. Well, it's close. There's motorboating in the radio. That's a bit of a warning. Next pin should have 110 volts on it. 1, 2, 3, 4. Okay, it's around 100 volts. 100 volts. It looked like it was almost exactly 110. The next one should have minus 24 volts. I think. I'm not sure what it's showing here. Minus 24 volts. See note B. Let's try the 24 volts. I don't know how you get minus 24 volts anywhere but a grid. So it doesn't quite make sense. That would be, it's just this diagram is it's not clear what the note refers to. Minus 24 must be the so we'll go 175 on pin number 876. 175 on pin 6. And we'll do the grid in a sec here. 175 on 876. Should be 175 volts here. We have about 200. And that's really it for that tube. So all the proper voltages are there. I'm not sure about this 24. Let's take a look at that. 24, if it's real, 1, 2, 3, 4, it's on pin 4. Pin, 8, 7, 6, 5. Pin 5, minus 24 volts. I don't understand it, but let's take a look. So we go 1, 2, 3, 4, 5. Oh, it's definitely a negative voltage there. Okay, it's a 50 volt scale now, 24 straight up. Oop. Oh, did you see that? That's 50 volts on there. Minus 50 volts. That sounds like something that would quiet a radio. How do you get minus 50 there? Could it be settings? I didn't do the settings on the radio here. Volume control full. Range switch on broadcast. Antenna grounded. Dial set. I don't think those matter on this kind of reading. Minus 24 and we get minus 50. What is that pin? Anyway, 6A8. 6A8. Let's take a look. See what's up here. Pentagrid converter. It's a very, very busy tube. Pin 8. Did I say 8? Why? I don't know where I got where the 8 come from. We're looking at pin 5, are we not? Pin 5. 8, 7, 6, 5. Heater pin. Oh, whoa. Hold on. I'm out to lunch here. I have wandered off. Let's get back to where we were. It was pin 1, 2, 3, 4. It was pin 5 with the big negative. So pin 5 on the diagram here. 5 is the grid. That's very interesting. 5 is grid number 1. Probably has the oscillator output on it. Oscillator grid, pin 5. I shouldn't really say oscillator grid, I should say mixer grid. Pin 5. Well, looking at this offhand, it's not going to help me sort out what's going on. Is this really true? Am I really getting that kind of voltage on this? Let's skip to the 3 bias resistors at this point and just see what we got happening there. It's supposed to be 19 at the start, isn't it? Let's just see. This isn't going to be 19 at the start. So this is 20. And then the next one, oh my gosh, measured across one resistor. I can't do that with this. 3.5 measured across resistors, 29 and 54. 29 and 54. Yeah, just work my way down. 29 and 54 is this reading here. The reading is 15 volt scale. We're getting 4 volts. And what is it supposed to be? Minus 3.5. So, that's pretty close. And then the last is minus 1.5. And that's up here. And that looks more like 2. Slightly higher biases, but not out of the ballpark by any means. And the minus 19 is really close. Is that what's showing up right on the grid? Let's see, the minus 19 comes flying up here. It's through a big resistor. We should find it up here on pin 8. They put the pin number there. Pin number G. Oh, for crying out loud. 6F6 output tube. 6F6 output tube. And we're looking for the grid. Grid is on 5. Well, that's the super high negative. Wait a minute. Does that all make sense? No. That's a different tube. So on the output tube now, grid number 5, pin number 5, 8, 7, 6, 5, where the green wire goes. So we got a whopper of a bias there. Well, this would explain why the radio's so quiet, if there really is a 50-volt bias there. How does that happen? How do you go down to the resistor string, get 20, get the other end of this wire, get 50? 50 negative, right? Yes, 50 negative, not 50 positive. How could you possibly do that? 19 here, or 20 in fact. Oh, I'm on the 15-volt scale. That's how you do it. That's how you do it. Okay, so you have 20 here, and then on the grid, which was it 5? Wasn't it 5? 5? 8, 7, 6, 5. It's the same voltage here. Yeah. Okay, so we got definitely the proper bias on this tube. Now we'll look at the other ones. See what's let's go back up to this is the one that had the wild reading, isn't it? Let's do that again. Ooh. Was it? What, that was 6A8? Was it the 6A8? That's got wild readings, and that's another reason why this thing wouldn't work. Let's go around again. Starting right with the start. Start with the start. We should get, you can see this is grounded. Get a 0. 0, 0, 0, then 255. 0, 0, 0. 0, 0, 0. Wait a minute, I count them. 1, pin 3. Come on, pin 3. Okay, pin 3. Ooh, 255 on pin 3. Oh, right, negative. There we go. Okay, I'm with it. I'm finally caught up to myself. It's just under 300. 255. Boy. Then we should have a 0, a 0. Yeah, I'm mixing up tubes here as I'm doing this because 255, 110 on the next. 110 here. That's right on the money. Don't get confused now. 20 minus 24. The next pin. Minus 24. Oh, this has got a green wire coming to it. That's minus. Well, we're way up on too high a scale here. 50-volt scale. So there it is again. So instead of minus 24, we have minus 50 bias pushing this radio. That would silence that tube. That's quite likely into cutoff. Possibly into cutoff if you can cut off that tube. So wild bias, and then we have the grid potential, which I'll check in a moment. Then after this, so at 175 volts positive on the next pin. After the green wire grid attachment, this one here, we should get 175 volts. That would be a yes on that, boy. So it's 200 volts. And that's it. Except for the grid cap. Let's look at the grid caps. Well, I'm using a VTVM. I can get away with this, I think. These should all show some kind of. That's kind of reassuring. You can hear that. 15 volt scale. Got some kind of bias there. Small bias here of a couple volts. Minus 7 volts. Why am I reading that? I'm getting a high. What's going on here? There's a grid cap. So what is that pin? Pin that has a negative voltage on it. That would be 1, 2, 3, 4, pin 5. I'm going around in circles here. 6A8. Pin 5, 6A8, 6A8. Pin 5. Right, oscillator grid. Oscillator grid. Well, so the oscillator grid bias is usually developed a couple ways, but one way is by using grid leak and blasting this with a 50 volt signal. It's not ridiculous, but the radio itself is expecting half that voltage there. What's that mean? So the fact that it's a big negative voltage, where does that come from? Well, it has to be generated right in the grid by the grid leak technique. So how is this wired up then? 6A8. And we see, oh, okay, oscillator grid. Oh, down into a switch and everything else. So what happens if we change bands? Do we get away from all that? We select different sets of coils here. We get a different result on the oscillator grid. Oscillator grid. Oscillator of the. It's not really oscillator grid. Well, I guess you could say it that way. Go on the grid. Pin 5 where there's the voltage. Again, I want to clip on my voltmeter here so I'm not holding it. Chicken. There we go. Okay, and we put this on the voltmeter here. Pin 5 of the 6A8. There it goes. Not going to go to 50 volts. What did I hook up to? How come not to 50 volts? 30 volts. Oh, I know why. I didn't have it on full voltage. Right around 50 volts is what's coming out of there. Now I'm going to change bands and see what happens to that voltage. That was the idea. Now it's way down. on one of the short wave bands now, which I haven't really experimented with at all. Let's put the non-antenna on. Nothing coming through. Come on, radio. Not a thing. I'd expect a lot of noise from that. A little bit of noise there. Okay, let's go with it. How do I know this is done it all right anyway? This wire sticking out the back here. How do I know that's really the antenna wire? And the guy didn't mess around with this somehow. This black wire here is going to the chassis right up there. So it's grounding out this green wire, or we can see this. So it's showing the 3 terminals here, and it's showing the link. Okay, so this is supposed to be the link now, the permanent link. What's the other wire doing? The other wire is coming in, going straight to a switch terminal, and has a coil dropping off it. So this is going straight to a switch terminal. As for where the coil is showing right on the wire. Oh, it should be right on this terminal. It's not there. And there's a variable capacitor. It's kind of smudged on the diagram with it. That's probably this. So put the color of the wires there. That would have been really helpful. What are the chances the antenna's hooked up to nothing, really? No. I can separate these wires and hook up to them and see what happens. No reason to hook up to the black one. It's the green one that I'm thinking is probably the one that's supposed to be doing the thing here. I can't really trace them back. They disappear. That green wire. Oh, the green wire goes out a hole and goes up to a coil on top. Green wire goes out to a coil with a capacitor right up on top. I think this antenna's all wrong. Let's just mess around here. I mean, ultimately, I'm probably going to reattach these to these screws. I have no idea why somebody got rid of it. Maybe the link got lost. Ground. D. And A. D. What's D? What is D? It's showing there. D. On the diagram. G and D shorted. G and D short, so it's conceivably these two. You know, everything could be just fine here. Somebody really put the twist on these wires. Holy smokes! Green insulation's just breaking away. Okay, so now I've freed up the green wire. What have I really done? I don't know. Let's find out. Wouldn't that be something if somebody did that and accidentally just basically grounded the antenna on this radio and that was the end of it? Again, I have a hard time believing that could happen. Okay, let's give it all the... Okay, we're back to making the same sound. Volume down. And what happens? Nothing at all. Nothing at all. So that great theory went down the drain. I thought, hey, maybe the radio will come right to life here. Back there. Well, that was fun. So what have I found out? I found out the voltages are all a little high, except the 110 for some reason is on the mark. There's a minus 50 volts on the oscillator grid. It would suggest the output of the oscillator is double what it should be. That sounds kind of nutsy too. The oscillator's oscillating because when I tune, things change. Oh, that doesn't sound right. Ooh. Wow, that suggests something really is wrong. Well, I think my next step is just start working on the alignment. It could be the radio is just stupidly aligned. It's not very likely though. Start working on the alignment, and in the process, maybe I'll encounter what the real problem is. I'm stuck otherwise. So let's do that. I could just feed in an oscillator signal into here too. How's that going to help? Adds to the fun. That's how. Okay, let's put this back on what I'm pretty sure is broadcast. Okay, I'll take the antenna of nothing. Now that was not switched on. It's just a long wire in my house. Probably a lousy thing. Now this is the signal generator. Let's see what we're up to here before I hook it up. Okay, we're at 9 megahertz, which is a little high for the AM band. Okay, we're about middle of the broadcast band. Output level is what? Way high, way high. I'm calibrating it here. It's 100 microvolts heading for the antenna at 900 kilohertz. Heading for this piece of wire that's hanging out the back of the radio. That's what I really should be saying. Not exactly getting a big response out of the radio so far. Okay, the radio's tuned right around 900. We're going to tune this rather than the radio because the radio's a struggle to tune. And we should go by where the radio's tuned. We should hear it. A little thump thump. Nope. 10 times the power. Nope. 100 times. Nothing at all. Okay. All she's got here. Not a thing came through. Nothing. Yeah, we did listen to a radio station with this radio. I know we did. Let me do this. I'm gonna. Oh, wait 1 second. The bias voltage just disappeared here. This was going over to 50. What's happened? I'm on the over 50 spot. Am I not? So I was changing bands. Maybe I didn't get all the way to the... What was that? really inconsistent behavior here. So first time I did this, it was high negative voltage on this pin on the broadcast. Now that's gone on the broadcast, but now it's showing up on one of the short waves. Oh, in heaven's name, I separated these wires and did not reconnect them. That's not the best way to have this operating here. So this green one, the black one really is just a wire to the ground. So let's use our own wire to the ground here. So ground this guy. What happens to that voltage? I can put my arm right in front of it. Nothing whatsoever happened. Nothing. I'm not sure at all what I'm doing, but let's keep doing it. Okay, so we're back to what I think is broadcast, shortwave, and now, is this the broadcast band? It's going to be one end or the other. Over 50 volts. So the thing is like behaving backwards to the way it was before. So how can that possibly happen? So I'm going to tune the signal generator and just see if we are in fact on the broadcast band. And it's full blast coming out of the signal generator. Let's not stop there. So what's happening here is I'm hitting that antenna with a heck of a signal. It's coming through with a powerful heterodyne. We're getting a steady state voltage on this pin. It's still over 50. It's supposed to be 24. That voltage is based on the output of the oscillator. I come back to the idea the oscillator is running twice as strong as it should be, which is kind of nutsy. So, the fun is running really high in here this morning. Holy smokes. Can we look at the oscillator signal? Why don't we do that? I'll put it on the SDR here. We'll take a look at it. Okay, so what's in the top corner of the screen now is the frequency display for my SDR radio. That's the SDR radio inputs here. The radio itself is sitting right there. This is coming all the way over to nothing more than having its clip leads connected together, which makes it kind of like a loop. A really single turn loop. Looks like a short circuit to me, but all I'm going to do is wave this around the radio and you'll see like stuff happening there on the screen. Now there's one signal which is just standing out above all others when I bring it up. It's right at 1300. That's the local oscillator. It's screaming out of this radio. And even out here I'm getting it. Now the SDR software defined radio we're using, it has its own automatic level controls and things like that. So as you see, as I'm getting closer to the radio, those other signals seem to be getting smaller. It's really because that oscillator is getting a lot bigger and the radio is quieting itself. The radio's at every turn. Very, very odd pattern of signals coming and going. What happened right there? Right there, what happens right there? That's really odd. That is really odd. Can't hear any of this in the radio. So, okay, let's get on to forget about the odd things. So the really strong signal is the local oscillator. It's at 1300. 1300, and you take 455 away, or 456 away from 1300. You get 8 something. 8, do you? What do you get? You get a headache. That's what you get. You get you get a chance to use the old calculator, which almost never works, but let's give it a try here. So it would be 1300, and we're going to subtract away 456, and we get 844. The radio is actually trying to convert 844, and what signal? 837. So local oscillators here, loud and strong, running on the broadcast band. So we are now on the broadcast band. I think I had the band switch reversed. And to add more certainty, I'm going to run it in my shop. I'm going to look at the front of the actual radio cabinet and see if it indicates the position of that. Well, there's nothing written on the cabinet at all. So this is now in the opposite position of where I would have thought. I would have thought broadcast would be this way, but it looks like broadcast is this way. I got to prove this. So we can see the oscillator right now on the SDR. Snap this one snap. Oh, okay. What's happening here? What happened there? Okay, so it's funny. I'm having a little bit of that sort of video screen problems. You see the two fairly bright white lines. I can see only two, but I know there's three because I have another screen here. So the invisible line is coming and going, proving. Maybe you're watching this. Maybe you can see it. It's a weird thing going on here, but it's anyway. Okay, so that's definitely there. Definitely there, even though you can't see it. Go to the next. It's gone. Where is it? So now I'm probably on the middle band. I don't know where I am. I'm either tuned. I know what frequency I'm on. I'm either tuned to 3 megahertz or 9 megahertz. So what I'll do is we'll go up to 3 megahertz on the SDR here. So if there's a local oscillator, it's probably this. All I got to do is tune the radio. That'll vary the local oscillator, and we can verify. Now, as I'm coming to realize more and more, the one I'm interested in is this one. Okay. When I'm doing this with the SDR and looking at signals coming out of the radio, and look how I'm picking them up. I just dropped the clip lead here, and it's just, who knows what's coming out of this radio that's hitting that clip lead. Well, you know what it is? It's a lot of different stuff. I'm starting to realize that the radio like this, any superhet set that's doing a frequency conversion, is probably got a mess of signals running around inside it. Just in front of the IF circuits. The IF circuits can only hear 455 kilohertz. So all that other stuff is nonsense, but it shows up on the SDR screen. And I've been doing this for a couple of years now, and every time I see it, I think, what is that? Well, now I'm starting to conclude it really is real signal. This is what I'm talking about. All those things moving on there, that's all real. That's really in the radio. You can't hear any of it unless some of it crosses the... look at this weird effect. They all join up here. Strange stuff, eh? But really what we're looking at is the local oscillator, which is the red line, which is now... I'm gonna put this... I'm gonna tune the local what I believe is a local oscillator to 455. Okay, so that's roughly there. And so that should be tuned to 3 megahertz. So I'm looking, well, I don't know, 2.5 or 9. Is it possibly 9? Is it just wild enough that... So oscillators can produce more than one frequency? They shouldn't, but they can. Oh my god, there's something right at 9 there. Tune the radio. Does that move? Oh my god. Okay, so so there are signals everywhere in this radio right now. Oh my gosh. I can't even figure out what band I'm on. So in this case, the pointer is pointing, I'll point it right at 9. So it's pointing right at 9. The local oscillator there is roughly, well, it's about 9,750. That's 9,455. No, that's not right. I'm looking at the wrong line. You gotta tune, just a sec, tune to 9 megahertz. The local oscillator should be just kind of where it should be, around here. But I see something way up here. So this would be tuning. You know, I'm mistaken. I've been in here too long again. For 955, this is the local oscillator for 9 megahertz. Come on, radio. You can't be like trying to run all bands simultaneously. The oscillator can, really only oscillate at one frequency. Let's turn this. So it's just a new set showed up somewhere else, and if I tune the radio a bit, yeah. The short story here is that this radio's got a lot of serious problems, I think, which usually comes back to a component being installed wrong, which usually comes back to me. When a radio's this weird, there's usually something wrong in it. Well, I guess that kind of goes without saying, doesn't it? So I think I'm going to stop right here because I'm kind of going around in circles at this point. And I got a little bit of stuff here to ponder. I'll go through and verify the component changes I made, especially the most recent, the last few I did, and see if I didn't make some kind of mistake. Maybe I shorted something in there, or who knows. Okay, so thanks a lot for watching. Kind of a crazy video.